For a long time, if you're building shareable front-end functionality, you really only had a few choices. The first one is you had to write in pure JavaScript. The second is you had to use something like jQuery and require all your end users to import the same library. Or third, you had to write all of your tools using the framework of your choice. But nowadays, we have a much better option, and that is web components. So today I want to talk about what web components are, why they're super useful, and why I think StencilJS is the best tool to build your web components. So at the core, the idea of web components is pretty simple. It's really just taking HTML tags and building your own HTML tag. So this uses a few different APIs and specifications, specifically the custom element specification, the shadow DOM specification, there is the ES module specification, and all these tools together allow you to create your own HTML tags. So when I say they're custom HTML tags, it's similar to what you might have done in something like Angular or React, where you're building custom components, except now you're actually building it with a web browser supported specification. You're still using encapsulated functionality, encapsulated templates, encapsulated styling, but now you're actually building it in a way that the web browser understands without having to use any sort of framework code to actually drive and attach that to the DOM. So here's a quick example of a web component I built in pure JavaScript. So over here, you'll see that in HTML, I'm calling this new tag that doesn't actually exist. It's called image slideshow. Obviously, this is not a real HTML element, but over here, you'll see that in this custom elements API that I'm using with the specification I mentioned earlier, you can actually define an element by the name. In this case, you need to have it hyphenated. It is a requirement of the web component spec that it has a hyphen in it. And then you define a class. So this is actually going to use the class constructor or the class prototype. You're not going to pass an instance of a class. So in this case, I'm passing in the class of image slideshow, should be slideshow. You're going to extend the HTML element class. And inside here, I'm not really doing anything interesting. I'm creating an image element, and I'm basically looping over one of the attributes and dynamically updating the DOM. So there's no real event propagation. There's really no user input or anything like that. The only interesting thing I'm doing is taking in this image property from the consumer of the element and doing some functionality based on that. So just for this simple part, this isn't so bad. But when you start talking about events and input and output propagation, it gets a little more complex when you're dealing with the straight up web component API. So if you're writing a simple web component like that, maybe using the HTML5 spec is all you really need. But if you're writing a lot of components, or if you're writing really complex components that need user input or event propagation or reactive programming, something like StencilJS is where you really need to start looking for the tooling that's going to make your life a lot easier. So what is StencilJS? StencilJS is a web component compiler, and what they give you is TypeScript support, they give you JSX support, they give you really nice TypeScript decorators, and all of that compiles down to what we just saw, which was simple HTML5 web browser specified componentry to build your custom HTML tags. So ultimately what this means is you get to write your web components in modern TypeScript, JSX, and all the modern tooling, but you still, at the end of the day, get ES5 browser supported web components. So I said that it's a mistake to write any of your UI components in a framework, and I mean that. Because if you're going to write your component in Angular, that means somebody in React can't use it. That means somebody in Vue can't use it. And more importantly, that means in 5 years, when React, Vue, and Angular maybe aren't even around anymore as far as popularity, your component's dead. So imagine if we had all these Angular JS components from 5-10 years ago. Imagine if those are written in web components. And now all the date pickers that everybody had to rewrite, all the drag and drop tools that everybody had to rewrite, those could have lived on and continued to grow. So if you just think of all the man hours that have been wasted rewriting components over the last 10 years, from jQuery to AngularJS and then Angular 2, or from jQuery to React, or who knows what's going to be next, right? There's Svelte on the horizon. Maybe that's the new thing that comes out and everybody switches to that. So that's what's great about web components and about Stencil, is that now you always have core functionality that's going to work in whatever browser and whatever framework. And all you need to do is have the wrapping layer around that can interface with that now core component, if you want to do that at all. And what's great about Stencil is they provide this concept of build output targets that automatically build these proxy layers for Angular, for React, for Vue, and I think the Svelte one is in beta. And you automatically now have framework integrated web components, as easy as running npm build. That's phenomenal. We now have web components that can live for many years and can be embraced, and they can keep going without having to worry about what framework comes next. And this is something that really is powering Ionic at the back end, because they went from Angular 1, which was an Angular JS 1, and then Angular 2 and Angular 3 came out, and you had to shift your whole framework. So there's a lot of issue there for a lot of people trying to migrate not only their Angular code, but now their Ionic code on top of that. From here on out, we're not going to have that problem, because everything they write at Ionic is in Stencil becoming pure web components, and they just write a layer on top of it. So they now have their core web component layer, they have Ionic Angular, they have Ionic React, and now they have Ionic Vue. And that's going to continue down that path as new frameworks come out. And they can support these 4 different output targets because they're using web components and StencilJS as the core focal point of that functionality, of that theming, of that templating. So I'm just going to briefly go over some of the StencilJS projects I've been working on. Specifically, this one is for a software as a service boilerplate that I'm building. And I built all of the front-end functionality into StencilJS components hitting APIs. And I wanted to make sure that anybody can use these components. So naturally, Stencil was a good choice for me, because now I have web components that will be automatically used in the application. And if you decide to start integrating a JavaScript framework, whether it's Angular, React, or Vue, you can now use that with integrated components. So I built these few components here. So I have a login, a logout, registration form, reset password form, a basic spinner. All these things are native web components. So let's take a look at my login. So you can see this is all wonderful TypeScript. Looks very similar to what you'd see in Angular. We have a component decorator here that specifies what my tag is, where my styles go. In this case, I'm turning off Shadow DOM. Shadow DOM forces anybody to be unable to affect the styling of your template. So sometimes this is ideal. You don't want people modifying the styling. You don't want somebody, maybe there's a bootstrap theme at a global layer, but you don't want those kind of styles affecting your component. You can use Shadow True, and now any global styles cannot affect your styling unless you specify the ability to do so. In my case, I don't want that. I want anybody to be able to modify the styling internally, so I've made Shadow False. You can see these are my state components. So anything that is rendered to my template that needs to be reactive is going to get a state decorator. So for my login state of success or error, whenever this gets changed, we're going to re-render. Props, similar to what you would expect, it is a incoming property on the actual component. So I allow somebody to pass in a header property, and I'm going to render that down here without them having to do extra work to generate a header. Similarly, I'm using a redirect to property to tell whenever the form is submitted, let's redirect the user this way. And then I'm also outputting an event whenever there's a successful login. And you can listen to this as a standard event emitter coming out of the StencilJS library. And then you see our render function. And this is very similar to what you see in React. It is a JSX template. So it's very cool. You're kind of seeing some inspiration from Angular with the decorators around componentry, but you're also seeing JSX and this render function to actually keep your DOM updated. So standard JSX work here. Let's say whenever you do an on input, I'm going to set state. That's going to update my state property accordingly. And then it's going to re-render the DOM. So it's very natural input management. I didn't really have to think about it too much. I just set the state, and the state updates the DOM. It re-renders. I'm good to go. So very useful. The event emitting is pretty much the same thing. For me, I'm not really eventing any payload, so I'm just doing a .emit, but you can actually listen to these events through your JavaScript event handling. And that's really all it is. So now if I want to look at how to actually leverage this component, in my case, I have a little demo here. It's called My Component. This is essentially my kitchen sink of all my different components. So I just call Nook login. And now all that functionality that we saw, let's go back there. So on click, it's handling, hitting an API, setting access token, updating my DOM with some messaging. All that stuff is encapsulated inside of this HTML tag like you would see in a typical JavaScript framework. So what becomes interesting is we have the output targets that I talked about. So when I come to my StencilJS config, in this case, I'm doing a little bit fancier stuff as I kind of develop here. Fancy is not the right word because this is kind of actually garbage. So I take back fancy. I don't know what to call it. But Angular output target. This is the only one I'm using right now, but React and Vue have a very similar approach. You specify your core package. In my case, Nook UI Components core. This is my core web component library. This is my current library, core. And it's going to reference that, and it's going to build what they call the directives proxy file. And what this does is automatically generate an Angular layer that interops with that pure web component. And we'll dive into that in a second. So I'm going to show you how I actually leverage these components and show you how they work from a core layer. When I go to this header, all I need to do is import one of my output ES5 build targets, and that's just Nook UI Web Components. So this is going to actually attach all of my custom components to the DOM for use. And then when I go to my login page, I'm rendering basically MVC style template. I'm rendering Nook login. So now I'm just using it like it's a typical HTML component. That's all I have to do. Ta-da, web components with encapsulated functionality, encapsulated UI, encapsulated theme, available with just a script tag, and I can use the HTML element. So I talked about the Angular output target. What that does is it's going to generate this directives proxies file. And if you look inside of here, you can see Nook manage user profile with some inputs of header and subheader and outputs of profile update. Eventually what this ends up being is you actually get your Angular specific inputs, Angular specific outputs. So if I was wanting to use one of my core components as a Angular integrated library, I would be able to do that the same way I would typically use any Angular component. So let's spin up a quick component here. Just gonna type template. Obviously, I'm just kind of filling this out with junk. But if I was doing a template, I can now do Nook login, and we saw redirect to was one of them. We had header, and I can actually use this HTML input binding to do this. So my header equals hello, and that would pass through the same way you typically handle any sort of Angular component. And the React world is going to be very similar. I don't have a demo of it right now, but it essentially be the same thing. And you can kind of see how that works by looking at Ionic and how they handle their Ionic React and Ionic Vue libraries. So now they've built this whole framework of web components, but they don't have to manage 4 different framework integrations. And I think that's very important, not only for an open source project, but for a company, because maybe your company is going to move in a different direction in 5 years. There's no way of knowing, no way of telling the future. But if you're writing web components, you're future-proof because you just need to write those wrappers, or if you're using a tool like StencilJS, it's already done for you. So that's the general idea. Write your web components with Stencil, be future-proof, be platform framework agnostic, and have all of your tooling live a lot longer and be used by a lot more people, while still getting excellent framework-like tools and a wonderful build pipeline for you out of the box. So thank you for watching. My name is Kerry Ritter. This is another episode of Typecast. I'll see you next time.